we, with my chief, Anatoly Maslak, professor, doctor of science, are from Russia, from Cuban State University, and our investigation are related to a rash model, and we work with it about 20 years. It's the most direction. But at last few years we interested in CAT because in our university we use tests for students, and in our country is unified exam which starts every year in end of May for child in schools, in middle schools. And there are a lot of problems, and maybe it's the use CAT is the next step, and so we are very interested in this configuration. We need a new information, and we pleasure for any help, any consultation of us. And our university is located in the south part of Russia. It's like Russia, California, in the the coast of Black Sea, and it's very warm, maybe hot. Now it's 35, 40 degrees, and it's the place where not in 2060 will be Winter Olympic Games. It's a beautiful place and good infrastructure. And in next year, we in our country will be soccer world championship. So it's a very interesting place to visit, and we invite you to our country, to our region. It will be a great experience, and maybe conference later. And so for our projects, in our investigation we use interesting in rash model because it's very it's a universal model, and it has such pluses as a rash model transforms measurements made in dichotomic and rational scale in linear measurements. As a rash model measurement is linear, it allows using a broad spectrum of statistical properties and procedures. The estimation of person ability doesn't depend on unused set items. The estimation of item difficulty doesn't depend on the person sample, and item difficulty and person ability share the common scale. Also, the missing of some data for interaction person and item is not critical. System of testing is the simplest as constructed by the other similar systems. It is characterized by the least number of parameters, only the parameter of a person ability and only one parameter of item difficulty. It's the most reason to use rash model. The rash measurement rests on legible concepts, item difficulty and person ability. This trait and so of two persons or the more able one has a better chance for success than a less able person, no matter that the difficulty of the implied item. Similarly, the probability of success on the harder of two items should be less than the probability of success on the easier, no matter who attempts the items. We can see that on this picture. In this picture we see two items in rash model, and for all lengths from end to start in the person ability, we see that the first item is harder than the second. Second is easier. And when we use Birnbaum model, 3 parameters or 2 parameters, now it's a picture of 3 parameters model, we see that when we use a lot of items, we find few locations of person ability where the difficulty of each items are different. On the first location from -2 for 2.5, we see that the first items is more difficult than second. And in the last location part from 2.5 and 5 and less, we see that the second item is more difficult. So we don't say truly what the item is more difficult. So we can't construct the calibrated item pool using the Birnbaum model. No, in our opinion, so we use Rush model for simulation and for experience and for our analysis. The purpose of this research project is to analyze the measurement precision of a latent variable depending on parameters of item pool. We use 3 parameters. First, it's factor A, range of variation of items in the pool. This factor varies on 3 levels with the following range in logits. You see it. And factor B is a number of items in the pool. The factor varies on 6 levels with the following numbers of items for every factor, from 128 to 4096. We use so much items to receive good precision, the best precision. And the items are evenly distributed in each of the variation ranges. And a third factor, factor C, examinees proficiency varies and at 30 levels. It's the ability of pupils, of students in our experiment. The investigation was based on a simulation experiment within the framework of the theory of latent variables and using Rush model. Response Y is the precision of measurement of examinees' proficiency, which is calculated as the difference between the true levels of examinees' proficiency and estimates obtained by means of adaptive testing. So we develop a small software for this experiment, and I can show how it works. Maybe it works. We can choose the parameters of person. Then we choose the range of item pool. Choose number of persons or precision for experiment and value of volume of item pool. Compute estimates. Excuse me. It's many. Maybe. And save file of. Maybe it's, we can see what this is this file. very safe on desktop maybe. We get such a results for this experiment, for this generation, and can construct the all set for analysis of variance of these three factors. So come back to the presentation. In the result of our analysis, we can see the table of analysis of variance, of the precision of measurement of examinee's proficiency. So we see that factor A and B are mean, and interaction of AB is mean too. Factor A it's item pool, and factor B is the difficulty of the items. Factor C is the ability of pupils, and it doesn't mean. The following results we obtained. Factor E is significant, mean significant. The greater of the range of variation of items in the pool, the higher the estimation precision is. We can see it on the table 1. Second, factor B is significant, and the greater of the number of items in the pool, the higher the estimation precision. We also can see it in the table 2. And factor C, the people's ability, is statistically insignificant at level of A. It means that the precision of estimation of examinee's proficiency is the same within the range of their variation. The only significant interaction among all interaction is AB, the item pool and the difficulty of items. The significance of this interaction is explained by the fact that increasing the number of items in the pool decreases the effect of the range of variation of items in the pool. Figure 1. So in this figure we see that absolute error depending on range of variation of items in the pool and number of items in the pool. And when the items are very much like 4,000, the error is closer to 0. And it's no difference between item pools. But when items are not so much, we see that the difference is bigger. And so it's I suppose it's for us it's initial work, and we try to develop it in a practice, because we have a collaborated item pool for some subjects in our university. We have a testing system and have a lot of results, about thousands results, and our plan to next investigation is to use CAT algorithm, and so we arrive here and watch and listen and catch information about different algorithms, stop rules, to use it in our practice and base it on especially Rush model. And the next step, we try to develop a website, because in our country has no such work, and so ability to work with CAT, and in our time website is more useful for teacher, maybe not only in our country. And we realized this site, but now without CAT algorithms, and we should do it later, after this conference. So we pleasure for any help, any collaboration, because maybe it's interesting not only in our country this aspect. And thank you. Thank you for conference for this time. That's all. Questions, maybe? Or maybe go to the evening. Thanks.